Hi everyone, my name is Yi. I'm your host for Occupational Medicine Pearls podcast. Now, this is the last component of the non-ionizing radiation, and it is laser. I could never remember exactly what the laser stand for. I have to keep writing it down. What is laser? So, laser is light amplification by stimulated emission of radiation. That is really mouthful. The key is that stimulated emission of radiation. So it is not natural and amplified. So you need to have a tiny little source of light, and they are artificially stimulated to amplify the amount of energy or light it produces. I read about it, I watched that, and they're so cool. I still could not grasp the physics behind it, but it is really cool if you want to look up on YouTube. From understanding some aspects of its physics, so laser radiation is a form of electromagnetic radiation, and it is coherent, monochromatic, and collimated. These properties make it unique hazardous compared to conventional light sources of equivalent power. The beam in the laser light doesn't divulge significantly. It goes into the narrow band where it is supposed to go, creating extremely high level of irradiance at a point, even from low power lasers. So the brightness do not underestimate based on that. There is a classification of laser. Generally, there are four classes, but there are multiple subgroups, which is important. And the classes go from class 1 is almost no hazard to class 4 is that really high level of hazard. So class 1, and so it is safe under all normal conditions, no dramas. Class 1A is safe without magnifying optics and safe with optics. Class 2 is visible and safe due to blink reflex, so we can close our eye on time. And Class 2A, but if you had magnification, it became unsafe. And then when you get to 3, the alphabet change. So it is 3R. So it is still low risk, but it can be 1 to 5 milliwatt visible and blink reflex generally protective, which is still good. 3B is that direct viewing hazardous, and it is high moderate risk. Class 4 laser is direct laser beam, specular, and diffuse reflection. So it goes to other areas after reflecting on the surfaces. It can set the light things on fire. So fire hazard. Class 3B and 4 laser require formal laser safety program, laser safety officer LSO, control area signage, and all the standard occupational safety controls. And it also required training in Australian workplaces. So, who are at risk of exposure to hazardous lasers? So, medical and surgical laser that are used in eye specialties such as ophthalmology, dermatology, surgery, and dentistry. Industrial laser workers. So, if you're using laser to cut well or engrave. So particularly if you have oxycutting or another way of laser cutting to the steel or other metals, that is important. If their researchers use high power laser in the labs, and then we have rangefinders, target designator, or weapon specialists in the military, entertainers with laser light shows, and telecommunication who operate fiber optic technicians. So they are only problematic if the fiber optic cables are broken. What can happen? So laser has similar to other non-ionizing radiation, it's always going to be our eye and skin. We can always remember that with the eye, it will cause inflammation or burn, depending on the duration and dosage, and sometimes they are the same. Retinal burns are usually irreversible. Proceed with caution, and they can cause permanent injury such as scotoma, photoretinitis, corneal conjunctival burns, anterior uveitis. None of them sound good. And on the skin, it can cause thermal burn. It will be similar to sunburn if you spend too long on the beach, and photochemical injury from UV lasers. And if you are taking any other medication or plant or fruits, photodermatitis could also happen. Certain lasers, such as surgical ablative laser, create plumes, and they burn the skin, so they create aerosolized biological material. So although it is not direct hazard of laser, it is the use specific in the healthcare setting. In that instance, you will require local exhaust ventilation, and appropriate respiratory protection, even though the laser is only you need protection for your eye. So there is a term called nominal ocular hazard distance. It is a distance from laser aperture within which the beam irradiance exposure exceeds maximum permissible exposure. So that helps with how far we need to away from the source of the laser. And there is also a term called maximum permissible exposure. It is the highest power or energy density safe for and protected eye or skin exposure. That is defined in the standard. It varies by the type of laser, wavelength duration, and the viewing angle. So obviously, our retina is more sensitive than normal skin. I suppose we may not need to remember exactly those of that, but we need to know that these terms are there and need to know where to look them up. All right, how do we control that? If we can choose not to use laser equipment, that's the best. Elimination, substitution. Can we use non-laser tools to do the same thing? And engineering, we have beam enclosure housing. If there is interlock on access panel and door, so that if you open it, it automatically close power. There are labels and beam stop and beam dumps are present, and local exhaust ventilation for plume. From the administrative control, laser safety officer, and they has to check the equipment at yearly, so that is important. And you need to also have laser safety program if you have class 3B and 4 lasers. Have the control or restricted area signage and the lines, warning signs, so that people do not wander into dangerous areas. And PPE is that laser safety eyewear. So that's good enough. And obviously, normal sunnies are not going to protect laser, and it need to be specific to the wavelength. So how do we know? Well, we need to look at the specification of the each laser class that we are going to use and get the PPE or sunglass that protect the wavelength specific. All right, that's all for laser today and the conclusion of non-ionizing radiation. Well, I hope you find this useful, and until next time at ionizing radiation.